Are you ready? Thank you, Jess. We are today taking the very last notes for advanced algebra. No notes after today, all the very end of it. It's probably making someone somewhere sad, but today is the end. So yesterday, we took notes on permutations. And permutations gave us the number of combinations, or the number of, we're going to go with combinations just because I can't think of another word. When order matters.
Miss Rumsey, Amanda's here.
Fabulous, because I texted her.
Did you really?
Yeah.
There was a huge accident.
Okay, we're videotaping actually, so we should keep going here. Alright, so permutations, the order mattered. So it mattered, remember yesterday I think I gave an example of if everybody was to, if I were to pick 3 people and the first person got a great prize and the second person got a medium prize and the third person got a prize that wasn't that great but it was better than nothing, sort of. Order mattered. Or if you were being picked to be an officer in NHS and you had to be either the president, who doesn't do a whole lot, or the secretary, who does all the work, order matters. So in the permutations, order mattered. And we used the permutation function NPR, where we had the number of total people possible, and then R represented how many we were picking. And we learned how to do that in our calculators, and we looked at the formula a little bit. Today we're going to talk about combinations. In combinations, it's going to give us the number when order doesn't matter. So for example, the first 3 names that I draw, you all get to skip the final exam. Do you care if you're drawn first or second? Not really, you're just happy that you were drawn. Ooh. Or I'm going to pick 3 people to be on the dance committee. Doesn't matter which order, no, because you're all on the dance committee. So when order doesn't matter, we're going to use a combination. And combinations are in NCR. So permutations with the P, combinations with the C. So I try to remember to myself that the P's are picky. The order matters. That way I don't pick the wrong form when I'm doing it on my calculator. If order doesn't matter, then we actually end up with fewer combinations. So we have a formula for combinations, again, that we will never necessarily use because we have it on our calculators. Where we just plug in, again, the N and the R from here to our points, whether it's the capital R or the lowercase r, doesn't matter, it's the same R. And then we'll use our factorial key. Who remembers what factorial represents from yesterday? Anybody? If I said 5 factorial, that was the same as 5 what? Times 4 times 1. But we are lucky enough to have these lovely crafting calculators. So if you were to get yours out, for a moment please. And I've turned mine on yet today, there we go. Move it out of the big glare from the light. See if we can do that. Just like when we had our permutations and we said, like, we could say there were 28 children in our class and we are going to be choosing 3 of them, and the first one is going to get 1 prize, and the second one's going to get a different prize, and the third one's going to get this lovely blue marker. Depending on what the prizes are, depends on what number you want to get. So the order mattered, what order I was drawn. If I said there were 28 kids in our class, and we were going to select 3 of them to skip the final exam, the prize is all the same. So up here we'd have the order matters, You care what order you're picked in, so there's different combinations possible. Here, the order does not matter. So there are going to be fewer combinations possible. And we put them in exactly like we did yesterday. So let's go ahead and put those 28 pick 3 with the permutation where it makes a difference. If you get the first choice, you don't even have to come to school anymore. Ready? So we're going to say 28. And then if you remember from yesterday, you select your math key. And you need to arrow over to probability. And then select number 2 for NPR. And then we're picking 3 of you. So there's 28 people in the class. We're going to be picky about our prizes because they're different. And we're going to select 3 of you to give some sort of a prize to. The first person can go home right now and not come back. Just going to give you an A. The second person can stay here, but I'm going to give you an A. And the third person got that lovely blue marker. There would be a possible 19,656 ways that we could combine you. So maybe Seb gets the blue marker, and Tyler gets the stay here, and Bob gets to go home, okay? Or we could change those 3 to be each of those different jobs. So there's a lot of different options with that. If I said, I'm going to select 3 people at random, and you all just get an A on your final exam, that would be a combination. So you go ahead and put the 28 in that you just did a few minutes ago. And then math, and again, arrow over to probability. And this time, if you look down to number 3, it says NCR. That's just representing our combinations when order doesn't matter. So we're going to select that guy. I selected the wrong one. Give me a second here. Forgot to arrow down. There we go. And we're still going to just select 3. And now with fewer possible combinations. 3,276. Because does it matter if I pick Seb first and then Tyler and then Bob? Or Bob first, then Tyler, then Seb? Or Tyler first, then Seb, then Bob? No. Doesn't matter what order I pick them in. I all got a free exam. In the other case, different person got the blue marker every time. So it made a difference. There are fewer options available when we aren't picky. Is that okay with everybody? And that is literally just as hard as it gets. So the only difference from what we did yesterday is we use the permutation when we need to have it in a specific order. We use combinations when the order doesn't matter. No? Alright, that's good. Yeah.